Hello everyone. So let's start solving today's Leetcode daily challenge question. So the question is trapping rainwater to. So given an m cross an integer matrix height map representing the height of each unit cell in 2D elevation map, return the volume of water it can trap after raining. So here you can see this is a 2D elevation map. Okay, and we are given this, and here you can see this is the first row, second, third row, and here this water is trapped uh, in these cells. Okay, and we have to return volume of water it can trap after raining. So if you have solved the trapping rainwater one, okay, then come to this question. First solve that question, and this is the two, right? So then you will understand this better. Okay. So here you can see this height of map is 143,132. I will just copy this here and yeah, 143. Wait, yeah, okay. So here you can see 1 4, you can see 1 2 3, like this 3 and this 1 4, so that will be 4 3 1 2 3 or 2. So here in the second, okay, in the second row, in the second cell, how much water it can be like trapped is, this is 3, this is 4, so total volume is 3, but what is the height of that cell is 2. So volume is 3 but height is 2, so the water trapped is 1. So similarly here the volume is 3 but height is 1. So volume is 3, height is 1, so water trapped is 2. So 1 plus 2 is 3. And if we see this cell, that is fifth one, the volume is 3 again, but the height is 2. So total our answer will be 4. You can see. And if you see this example, okay, as we know, this first row and the last column, okay, we cannot trap any water in that. Why? Because see this you can see, right, this first, the second cell and third cell is acting like a boundary, okay, to this cells, so that it will this water will get trapped inside. But at this first row, first column, and last row, last column, this we will not consider, because there, here you can see in this example, this fourth cell of last row, you can see the empty, but the water will go right from here. There is nothing to like boundary kind of thing. So we will consider the last row, last column, last row, last column, first row, first column as a boundary. And wherever it is there, like this, here you can see boundary is there, so the water is getting trapped here, again here also. Okay, now if you see this example, 3 3 3, and yeah, here you can see this. So in this, these are our boundaries, this and this. Okay, you can see this 3. Now the water will get trapped in this middle, whatever cells are there in that only. So if we see this cell, okay, what is boundary is 3 3 plus, we have to check here also, right? Let's say if we have a like question example, like this is 2, this is 2, and this is 1, then will the water get trapped here? No, right? Because there is no boundary only here, because 2 is there, but there should be greater, right? Here you can see three cells are greater, and two cells are, like, of course 3 is greater than 2, but this 3 boundary will help this two cells to trap the water of volume 1 cell. Okay, so we need like a boundary, So we have to check here, here, and also here. So that we will like I will explain in some time, but let's check here. This is 2. Okay. From 3 and 3, what is the volume? High volume, like maximum volume is 3. So we can trap 3 volume of water, but what is the height? Okay, so that what I'm saying is we can fill 3 volume water, but what is the height? And we have to subtract height minus that volume, so that much water will get trapped. That will be our answer. But here you can see this is your boundary, this is your boundary, that is top and left. And again for the right and down, we have to check the this one. Basically we have to update. Okay, so for this two, we also should like there should be this three also in this example. Okay, like that we have to check bottom. So we have to check top. Okay, and top, left, bottom, right. In the previous question, in the last Leetcode daily challenge question, the similar approach I explained. That just the thing was like it was a little different, but approach was same. Okay, so here you can see top left, we have to check top and left. Again, we have to check bottom and right. Bottom and right. Okay, so we will use some another 2D array. Okay, and we will store there that for this cell, what is the volume? Okay, what is the volume? As I'm saying here, this 3 and 3, which is the maximum 3. So the volume will be 3. And at the end, we can calculate how much water we can trap by subtracting height from that volume. Okay, so we have to update this volume every time. So here you can see top left. Okay, for this example, for this one, what you have, this is a top and this is your left. Okay, so like basically this depends on this neighbors, like this, like top left and bottom right. Okay, so this should get updated. Let's say we are taking similar 2D matrix to update our volumes. We are taking one 2D matrix to update our volumes. Okay, that means for this cell, okay, what is the volume? And then from that volume, we will subtract our height and we will get the number for which the water we can trap that much. Okay, so how to calculate this volume is we have this thing, right? Top, left, bottom, and right. So for top left, we can say the in the yesterday's question, we as we were saying forward pass and backward pass. So similarly here also forward, like this will come from this side, and this right and right and down from the back side. Okay, so our iterations will be, this will be from 1 to n minus 1, n minus 2, sorry, n 1 to n minus 2, and here it will be n minus 2 to 1. Okay, and then every time we are updating. And also in the yesterday's question I explained that why we need multiple iterations. As we know, this depends on its neighbor cells, that is top, left, bottom, right. So if let's say this is not updated, this cell is not updated, our volume, this cell is not updated, how we will calculate this, right? So every time we have to check, and once we get our solution, like how we will know that our we got our volume matrix is, we will check if the data is not updating. Then we can say we got our volume, and at the end we have to just subtract it. Okay, just let's start coding. Is first, let's say int n is equal to our grid. Okay, height map dot length, and int m is equal to dot of 0 dot length. Okay, and we need one volume array, 2D array, which will store the volume into what, n and m. And initially we will fill what, we will fill our this array in that. Okay, so int I equal to 0, I less than n, I plus plus, volume of I is equal to arrays dot copy of what, our height map, of I, and we have to pass the column length also. Okay, now we copied this same thing, so now our volume matrix is this. Okay, now what we will do is we need, as I explained, we need number of iterations. So for that I will take, let's say, one boolean. In the previous question, we have used the 2D array, same thing, and every time we were copying and checking it. Okay, so here, because there we were doing directly mat.max, we were using. Here we will use the if condition, and in that if condition, if that condition is getting like it is true, then we will update our boolean value as true. Then it will automatically know that our data is updating. If it is false, that means our data is not updating, we got our solution. So let's say I will take flag 1. Okay, initially true, and we need one more flag. Let's say I will take init, which is also init, true. So basically this init is in the first iteration. Okay, in the first iteration for top left, we have to update irrespective of our condition. As I said, okay, what we will update here is, first we need what is the mat dot max. Okay, mat dot max of these two, not mat dot max of these two. This will be mat dot minimum of this, and mat dot max. Okay, I'll write here is, let's say I'll take int val is, what it will be, mat dot max of the current height, and as we are calculating volume, right? If the current height, okay, we have to check this, and mat dot minimum of what, this top and left. Okay, so we have to find mat dot minimum, because minimum we want, right? And height. So here if I say here it is 2, okay, and here it is, let's say, 1. Then out of 3 and 2, which will you think is the volume for this one is 2. In the first case, okay, we are updating anyway, we will update for right and bottom. For in this case, 2 and 3, which will be 2. So mat dot min of top and left. And why mat dot max? Because this 2 and this 1, volume will be this 2 only, right? Volume will be this 2, and of course let's say here our height is 3, then volume will be 3, but at the end our height is also 3. So if my volume is 3, height is 3, then no water, like water will not get trapped here. Okay, so that's the thing, we are calculating the volume. Okay, so this is the formula we are going to use it, and we will update it. Okay, so let's use while flag 1, we will just do the flag 1 equal to false, and then in our code, like it loops, we if we are updating, we will make it true. Okay, if it is not updating, automatically it will get out of the loop. Now first is forward forward pass, that is top and left. Okay, so for int I is equal to from 1 to I less than n minus 1, as we discussed. Okay, here first column, and last column are the borders. Okay, we are not, like, there is no point in checking the volume for that. Okay, because anyway water will not get trapped in that. Okay, first column first row, and last column last row. Now for int j is equal to 1 to j less than m minus 1 j plus plus. Okay, this two, like we are basically traversing this matrix. Okay, this internal. Now here we will calculate our value is equal to mat dot max of current is what, height map of I of j, comma, math dot min of top and left. Top and left, we are going to check the volume. Okay, so volume of top means I minus 1 and j, comma, volume of left is what? Left is I and j minus 1. Okay, and we are going to check if our volume of I and j, if it is greater than our value. Okay, if my this volume is less, not greater, if this my volume is less than my value, okay, then I will say volume is equal to val. Okay, and we are going to do this flag one as true. Okay, because we are going to update, right? So here currently, you can say here it was 3, and here it was, let's say, 1. Out of this 3 and 2, which is minimum 2, and out of this 2 and 1, which is maximum 2. So we will check if it is less than 2, then we'll update it as a 2. If my volume ij is less than val, then we will update as this val. And also, as we are taking init, this is for initialization. Okay, initially here what we did, here we just copied our thing. Okay, so in the first iteration, what we need is whatever the volume is, we have to, like, I don't want one here initially, I want two only, so that I will be able to calculate later. Okay, so that is why we are going to use the init here first time, init. Okay, and after this, we will write this init as false. Okay, if we don't use this, we will get a wrong value, because we will be going to use this value somewhere else, right? So for that, or this value, like whatever the first iteration, let's say this value, we are going to use somewhere else. So for that, initially we have to do, like, we have to update all the cells, and then next we will be seeing. Okay, so same thing here we have to do. Okay, not here. Yeah, here. And same thing we will do for which pass? Backward pass, which is what? Oh, what happened? Okay, yeah. So here, yeah, what, where we were? Yes. So here for backward pass, here what we want to do is from n minus 2 to I is greater than or equal to 1, and I minus minus, as we are not considering the first and last row. And here also m minus 1, sorry, m minus 2 to greater than or equal to 1, and j minus minus. Same thing here, only is right and down. For down it will be I plus 1, and for right it will be j plus 1. Okay, and the same thing here, we will remove this in it, and same thing. Okay, flag equal to true. And if this if conditions are not satisfied, okay, this condition is not satisfied, then it will not enter in this, right? So it will, the flag will be false. So at the end we will get out of the loop. Then we want our answer is equal to, let's say, initially 0. Then for int, here also from 1 less than n minus 1, I plus plus. For int j is equal to 1, j less than m minus 1, j plus plus. Okay, here what I said is, now we calculated the volume, maximum volume. Okay, now we want to calculate how much water get trapped. So that will be, we will check if my volume of I j is greater than height map of I j. Okay, then what our answer we will increment equal to, from that volume I will subtract my height, then I will get this like the answer. Okay, map height of I and j, and we will return our answer. You can say accepted. Let's submit this. So here we used this approach. Okay, dynamically we are okay. Let's check what's wrong. Initially we copied our array. Okay, here we are passing m, and from this I to I we copied, and then this is a while flag 1, and we are initially doing this flag 1 as a false, and from 1 to n minus 1 we are going, and from 1 to m minus 1 we are going. Okay, and our value will be mat dot max of height map of I j. Okay, and minimum of volume of I minus 1 j and volume of I j minus 1. Yes, and we are checking if my, okay, if my this init or volume of I and j, this current volume is less than what we have calculated, then we will update this and make our flag 1 as true. And in the second, okay, this is the forward pass. Now in the second, I is equal to n minus 2. From n minus 2 to 1, we are decrementing. From m minus 2 to 1, we are decrementing. And we are doing the same thing, only where we are like plus 1. Okay, because we are checking the right and down. So similarly for here, we are checking if my volume is less than this val, then we are updating. Okay, and my answer, let's check, let's print this. Volume of ing. Not for this, right? Yeah, no run. So it is 13, 13, 13 plus, what is the height? Okay, we will check. Height is 4. So 13 minus 4 is 9. 9 and this. So what is our example? Let's see. 5, 5. Okay. This is 13 minus 4. Wait. 13 minus 4 is 9. 0. Then if I do 8, we get 5 plus 5 plus 3. And then plus 1. So 18, right? Okay, expected is 40. Let's see this example will solve by. Just a minute. Yeah. So here 18. Okay, in minus we are taking this correctly. We are setting our flag. Mistake here. Let's check. Yeah, we made this mistakes. If our that this is greater, okay, then we will update our value. Okay, so let's submit. Yeah. Okay, let's submit this again. Okay, so see, in this way we have solved this question using this approach. First I'll remove this print statement and all, and then we'll submit. Yeah, you can say. So thank you so much for watching this video. If you feel this video is helpful to you, please like this video, subscribe my channel, stay updated.